All right, so today's lesson is about vertical dilations of functions. So we're still with the same learning attention, the knowledge of how the order of which translations and dilations occur will affect the function. So today we're going to be successful if we can correctly identify and apply the function f of x. If we get y equals k f of x, well, this dilates the curve vertically along the y-axis by a scale factor of k. So if k is greater than 1, the graph is stretched, and if k is between 0 and 1, the graph is shrunk or compressed. If we get y equals negative k, well, this reflects the curve in the x-axis. So let's do our basic, if we have our basic y equals x squared, yeah, we understand this one. If I obviously had y equals negative x squared, well, that reflects it about the x-axis, yeah. But if we had y equals k of x squared, let's say our k was greater than 1, so something like 5, what's happened is it's really stretched each point, yeah? So if we have here, this is x becomes 1, 1, this point here, yeah? But if I plugged it into the green function, well, that becomes 5 times. So x still is 1, but the y value of 1 is multiplied by 5 to give us 1, 5. Yeah. Now, if the function, if the scale factor was smaller, let's say 1/6 of x squared, yeah, it compresses the graph. Yeah. So this 1, 1 point now becomes a sixth of 1, so 1 and 1/6. Yeah. Okay. So let's do some examples. Describe how the constant affects each transform function graph given the parent function state the scale factor. So this is a linear one, so let's just change it to a squared. Okay. So if we have y equals x squared over 5, that's the same as writing it as y equals 1/5 x squared. So the k in this situation is a fifth. This is your k value. It is between 0 and 1, so it compresses the parent function a fifth of its size, and k in this situation would be 1/5. Okay. Here we get x cubed, so this we get 3 over, so technically we get 3 over 8 is our k value. Yeah. So what happens is there's a reflection about the x-axis. Yeah, so rather than the cubic looking like that, it's going to look the other way. It's going to reflect from the x-axis, and also it's compressed. As k is between 0 and 1. Okay. We want to find the equation of the transform graph and state its domain and range if we get y of natural log x is dilated vertically with a scale factor of 6. Okay, so here's your parent function. And what we want to do is we want to dilate it vertically. Okay, so the scale factor is 6. So when we want to change it, we want to change the function of f of x to k of f of x. So in this situation, our f of x is log of x, and we want to have a scale factor of 6. So we want to change it so that's going to be 6. So let's see what that looks like using decimals. So we get log of x, and now we're going to change it to a scale factor of 6 log of x, and you can see how it translates, well, how it stretches the values up along the y-axis. Okay. All right. Example. We have a point, 2m, we call it m. Its coordinates are 2, 6. It lies on a function. We want to find the coordinates when the image of m is dilated vertically with a factor of 3. Okay, so in this situation, what occurs is our y values change. Yeah. So our y values change, and in this symbol and this situation, because it's a dilation, is also multiplied. There's a scale factor. Okay, so if we have our coordinates 2 and 6, we're stretching the y value by a factor of 3. Okay, so our new point would be 2, 18. Okay. The second part, B. We want to reflect it around the x-axis. So this is going to be, it's going to end up having a negative value. Okay. Because we're reflecting along the x-axis. Yeah. And we want to dilate it with a scale factor of 1/2. So what we want to do is multiply it by 1/2. Okay, so our new coordinates will be 2, negative 6 lots of 1/2 is 3, so 2, negative 3. Okay. So that's when we're talking about vertical dilations. Yeah. When you have a function y equals f of x, and you have a k in front of the f of x, the scale factor, if k is greater than 1, the graph is stretched. If k is between 0 and 1, it's compressed. But if it's negative, it's reflected about the x-axis. Okay, thank you.